welcome to DSC UTeM second DevOps series event, which we'll be talking about Git, GitHub, and GitKraken. So before we start, let me just ask you guys, why are you here today? Because I know that some of you are here because your lecturers asked you to. No worries. I don't have anything against that, but still, I want to know like why you guys are here and like what like who will follow demo, how many percentage will follow demo, how many percentage will not follow demo, and so on, so I can time my pace accordingly. So yeah, just go to Slido. Can just scan the QR code on your phone, or you can just go to the link at your at the Microsoft Teams chat there. So yeah, if I remember correctly, you can take a few. Yeah. So I'll put in a few minutes for this. Not few minutes, just about a minute, I guess. Also, no worries. I won't know who you are, so you just vote as you wish. Also, for those that want to follow demo, as the first slide said, please make sure that one, you have a GitHub account. We will not be going through that. And second is, please make sure that GitKraken is already installed on your computer. Yeah, we also won't be going through that. And for your convenience, if you are following demo, I would personally recommend that you use a phone, and you use your phone to listen to what I'm saying, and your laptop for you to do the hands-on. So it will be more easier. You won't need to switch windows, and you can always see what I'm doing. I'll leave this out for a little while more. Okay, I think the voting stopped. So apparently most of people will follow demo. So I think I will speed up the previous section, and I will focus more on the demo. So thanks for the feedback. Okay, next. Okay. How do you usually collaborate code? Let's say you have an assignment. You have maybe 4 or 5 team members. How do you submit your part to your let's say group leader, or I don't know, depends on who is managing a project. Usually what do you do? Okay, I think apparently most people send zip files. That is also quite normal for me personally if I don't before I start to use Git. But yeah, sending code across chat messages, seriously, the whole thing will get formatted, and everything will be not nice. But still, it's still a way. Okay, I think the result stops coming in. Okay, and then we'll move on to our last so-called ice-breaking question. Okay, this is a free question. What happens, or what will you do if, let's say, your FYP code suddenly deleted itself just right before submission? 3, 2, 1. Okay, start answering. No one? Try historically. Pray. Furious Rage. GG. Redo. Throw laptop. Okay. Oh my god. Always have a backup. Okay, good. Good for you. Okay. Nice. We take the stem. Okay. Sleep. What to do, right? Already delete. What? Why not sleep and try again? Cry. Tell supervisor. Okay. Quit study. No lah. Don't do that lah. Kill me. No. Okay. Call for GitHub. Okay. You are a pro person here. Kill me. No. Don't kill me. Okay. So the reason I'm asking this is because according to what I know, someone from some course in FPMK, in our uni, his code actually disappeared. Not actually disappeared. His hard drive, I think, broke. So he had to redo his whole FYP, and then after he redo his whole FYP, the thing broke again. So he basically, I think, need to retake the SEM lah. This is what I heard lah. Okay. Okay. So thanks guys for answering this question. We are now at 91 attendees. Thank you everyone. Wait a second. Okay. Okay. So now let's go to the next slide. Okay. So yeah. Okay. So before I start, let me reshare this using new. Okay. So okay. Yep. So a slight disclaimer, of course. First is that any opinionated statements are of my own and is not related or does not represent the DSC UTeM whatsoever. Because I know that maybe I will throw out some opinionated statements about some stuff. So it's of my own. It's not related to the DSC UTeM. Okay, next is contents presented here are purely for educational purposes only. So if let's say you want to use it for malicious stuff, you are responsible for your own actions. Okay. Hey, web session housekeeping. So before we start, remember to always mute your microphone unless prompted. I think you can't unmute it also. Yay, teams. And there will also be a Q&A session at the end. So please take note of your questions and then ask them. I won't fight. So how to do it? The slides behind will tell you. Okay. And of course, at the end, we will have a survey. So please do tell us how we did in the survey at the end. Okay. And also, today's webinar is being recorded. So I won't do the same mistake I did last week. Sorry. I will share the link after the event is complete. Okay. And also slides will be shared after the event. And on a side note, non-UTeM students, only sign in UTeM students, I think, can write in chat. So this is a Microsoft Teams policy, and I'm sorry I cannot do anything about it. And if you are here by the request of a lecturer, please do sign in to a UTeM account so that your attendance information can be passed on to them. Yeah. Okay. So event hashtag DSC UTeM, DSC Google Developers, DSC DevOps. Okay. So for Q&A, please submit your question at the Q&A tab of Slido. So I just recently opened up Q&A. So anything you just submit there. And if let's say you see anything that you like, you just like it. So they won't have duplicate questions and I can answer them more efficiently. Yeah. And I'll just share the link inside the thing. It's the same link as the small thing just now. Okay, I'll put this out for a moment. Okay. I think everyone got it right, hopefully. So if there's anything, please do tell me so that I can resolve it as quickly as possible. Okay, how can we sign our attendance? Just log in here and that's it. I will send the name list because after this event, there will be a name list and it will be sent to your lecturers if you are here by your lecturer's request. Okay, so I'll assume I answered that. How do I answer that? Okay, so today's agenda. So today I will give you guys a really brief history about Git and a software configuration management or SCM tools in general. And I will later on give you guys some simple Git operations and concepts, and later on tell you how GitKraken, GitHub, and how it helps. And then I will do a short demo that you guys can follow on and a Q&A session. And also, I will have an extra. First is how to make sure everyone contributes in an assignment, because I know that for a lot of assignments, people just sleep and not do anything. So Git is a way to make sure everyone contributes. So it will not be an extra anymore. It will be under the agenda. And of course, if let's say you want to know more, you can stay after the Q&A session for some extras on the underlying mechanism of Git. Okay. Okay, no questions so far. Okay, so let's talk about the problem that we want to solve today. So the problem is, you can see here, I think this is what many people, when they just want to version their file and let's say, okay, I want to test if this file works, I want to test if that file works, and if it compiles or not, or if the HTML file, this version, that version, and if let's say my lecturer say, okay, I like the first version, then I can just copy that. Okay, so this is the problem. And the problem is that it's very difficult to keep track of work done. Why? Because let's say your group leader will give all the team members their own jobs. And let's say if a team member wants to submit like for the group leader to merge in. So what the group leader has to do? First, you need to identify the change points, what team member one already does, right? So it probably can be managed through email or chat, maybe. But what if your team is big? Okay, so the group leader will have to take in everyone's code and then merge it in. And sometimes, if you are coding in Python, face some formatting issues in the process, because sometimes when you copy from this part, it is not properly indented as compared to other parts. Yeah, personal grudges against Python. Yeah, so indentation will be a big issue. So after getting the code, the group leader will still have to test and then redistribute to all the team members. So let's say after he gets the code from team member one, and they'll give to team member two and say, okay, now this is the latest code, please integrate with the latest code. And then later on, those team members will have to merge their code in and then test in the process. And then maybe later on it says, okay, why it works on your computer, it doesn't work on mine. And what if during the merge, suddenly team member two say, hey, I have something new, I want to give you. And then the group leader say, ayo. So the group leader will start to flip table. So multi-people projects is definitely hell without proper tools. What if you realize that your current code is so screwed up, you want to go back to a previous version? Or what if your supervisor or your boss says that this code, I like the first version? What if the boss does that? Or how do you keep track of changes from version A to B? What lines have you changed? You don't know, because it's just a dead file there. And then what if at the end your computer explodes during compiling the last version of your FYP? Or if something happens to your code, you will die, basically. Okay, so this is what happens when you don't use proper version control. Yes, this is a live code. I will give you some hints to where to find it if you are a UTeM student. It's in a system that has the letter S and M and P in it. So I won't tell you the system, but if you are smart enough, you will figure it out. So what happens is that the code is here, and then they just put a line and say this is the edit, and then they start to edit, and say, okay, this is the end of the edit, and that's it. So If let's say you have many edits, you'll go this. What is this? I'm so confused. If let's say the changes within the changes, there are changes from other people. Wow, if you use this kind of system, your code will be very cluttered, right? Okay, so here comes SCM tools, or we call software configuration management tools. Okay, so in general, there are three types of repositories. A repository is basically where you store your code. Okay, so there are three types of repositories. One is a local repository, which means that the repository stays on your computer and only on your computer. Okay, the second is a central repository where everything is in there. So a very good example of a central repository will be a Google Doc. Okay, everyone edits the online version, and if let's say you get disconnected or Google suddenly gets shut down, you cannot pretty much do anything, right? You just stand there and cannot do anything. Yeah, I know Google Docs have offline syncing, but still, the initial version is based on a centralized repository. Okay, and last we have a distributed repository, which means that the server you can see there has its own code, and in computer A and computer B, they have their own version of the code, and they maintain their own version database. So let's say if your server explodes, you can say, okay, I can restore from computer A. Or sometimes maybe computer B say, hey, this code has problem. Computer A and server say, no, there's no problem. So computer B can just delete everything and just pull from the server computer, right? So in general, version control, there are centralized and distributed. So centralized, everyone must be connected. You screw up when your server screws up, but it is very good for binaries. So binaries are basically images, videos, cat files. Anything that is not text is called binaries. And of course, version control for centralized, it's good for central safeguarding. You don't want someone to access your code, you just block them off. That's it. Okay. So distributed is you can work without being connected. You can work for private. You can do for private work or experimentation, and you can prevent single point of failure. Let's say if your computer or your server goes down, the code won't go down. Okay. Okay. So these are many types of version control software out there in the market. So Git, Gitkeeper is Gitkeeper, and the one pointing arrows here is called Bazaar. If you are doing Adobe Creative Cloud, there's also this thing called Team Projects feature for real-time collaboration, and that is under a centralized repository. And Subversion here is an example of centralized version control. So why are we choosing Git to learn today? Because Git basically takes up about 73% of the VCS market. And Subversion there is a centralized repository. It takes up most of the market that it basically does what it does. Okay, so what is Git? Basically, Git is a free and open source distributed version control system designed to handle everything, small to very large projects with speed and efficiency. So later on, I will tell you how fast it is and how efficient it is. So one, a brief history of Git. So Git was founded based on frustration. So this project basically changed the world. Okay. So yeah. Okay. So this is Linus Torvalds, a software engineer that is born in 1969 and released the Linux kernel in 1991. So more about Linux in our upcoming sessions, but basically the Linux kernel is free and open source software that powers about more than 95% of the internet. And this is Linus Torvalds of the Linux kernel, not Linus Sebastian of Linus Tech Tips. Okay, so why Linux? So Linux in 2002 is the largest and the most active open source project in development. So there are about 418 notable developers in the contributors file, but these are notable developers. There are also so many people that are not listed there, and there are about 3 million lines of estimated code. So before 2002, Linux was managed through an email system where developers submitted patch requests. So patch requests are basically say, okay, delete this line, add this line, and so on. So it was a very tedious task, but still they barely managed to cope. Now let's look at the code base of Linux in these days. So as you can see from 2005, it's about 5 million and about 2020, it's about 3 billion lines of code. Yeah, so by 2005, there were about 6 million lines, I guess. So they desperately needed something to save them from all of this. So Linux, they initially used BitKeeper as a VCS, but the copyright holder of BitKeeper, so he took off the free product section because this guy called Andrew Trigdale, he reverse engineered BitKeeper, which was somehow against the BitKeeper license terms. So, and also previously when Linux chose BitKeeper as their version control software, many people were against it because they said that, okay, BitKeeper is a proprietary software and a proprietary software should not have control over an open source software. So yeah, Larry McRoy withdrew free use, and Linus Torvalds set out to find a replacement that one, had fast patching, two, supported a distributed and a parallel workflow, and include extremely strong safeguards against any corruption. Okay, because it was such an important project. So at the end, he couldn't find one, so he just wrote Git. Yeah, this is Legends 2 stuff. You cannot find anything there, then you do it. Yeah, so over the weekend, about 3 days, he wrote Git with this criterion. So first, patching must not take more than 30 seconds because anytime he pulls in any code, about more than 250 such actions will be put at a time. So if let's say you take about 30 seconds for each patch, maybe each pull will take a few hours. Okay, and of course, Git supports a distributed and parallel workflow, which you will see later on, and include extremely strong safeguards against corruption. This is what the properties of the distributed version control has. So this guy, he basically wrote the first iteration over 3 days, and then the rest of it within a week. So because programmers spend so much of their time on thinking what to name their products, so what does the name Git stand for? Because this is fun, so I want to share to you guys. So what does Git stand for? So the name, according to Linus, depends on your mood. First, Git is a random 3-letter combination that is very simply pronounceable. Second, it means the stupid content tracker, because Git means stupid in England slang, if I remember correctly. And if everything runs good, it's called the global information tracker. You see everything and the code, and everything is nice. But if it breaks, it's called the goddamn idiotic truckload of shit. And I did not make this up. You can see the GitHub repository, which is there, github.com/get/git. There, I did not make this up. So, okay, so after Linus finished the code, he just sent this code and assigned this guy called Junio Hamano to maintain the code. So he started maintaining the code on July 2005 and is currently employed by Google. Okay, some side notes. What happened to BitKeeper? They went open source on 2016 and basically stopped development now. So probably this is what happens if you don't embrace open source, I guess. Now I will talk about some simple Git operations and concepts. Okay. First questions. What is a repository? What is a remote? What is branch? What is commit? So first thing is a repository. So a repository is a place where you place your code and basically just everything that comes with it. It can be on your computer or it can be not on your computer. Yeah, that's a typo there, sorry. So if it's not on your computer, it's called a remote repository. It's a Git repository that acts as a source of truth. What is source of truth in this sense? It means that if anything happens, if let's say 10 people have 10 different versions, we always refer to the remote. The remote is always correct. Okay. So the remote, this term usually refers to a centralized server, or we call origin. So for example, if there's actually you can find any repository at GitHub, it's a remote already. Yeah. And next concept is called a branch. It's basically a movable reference, which is basically a label that you can move around to a series of commits. More about commits on the next slide. And then if let's say you want to fix a reference, it's called a tag. And then there are two major types of branches that I will talk more about later on. But now you just need to know that there are two major types. One is called volatile, which means that it always changes. One is called stable, which means it's stable. So if you fork code on GitHub, you basically create a branch also. And in some software projects, you will see the term master branch instead of the main branch. It actually essentially means the same. So previously, they used the word master and it changed to main because the Black Lives Matter movement in the US. So they said that the term master was coined with slavery. So yeah, so at the end, do I get a master's degree or main degree, right? Okay, next slide. Yep, okay. So a commit. A commit is a snapshot of that code at that point in time. Okay. Git, different from centralized version control software, it saves a version of the code every single time it is committed. And a hash will be generated based on the root commit. So it will tap out everything and it will take the commit hash of the previous commit, merge it together to generate a new commit hash. So that will be your commit hash and it will be unique. So if you want to know more about that, stay for the extra session about how this whole thing works. Okay, and now we go through the file lifecycle, which basically is what happens during Git. So first is when you initialize a repository and you make a file, the file starts by being untracked. And after that, you stage the file. And by staging the file, you say, okay, I am ready to put this and commit it. So after you stage the file, you commit it and it returns to being unmodified. But now it is being tracked. Okay. And when you modify the file, you stage the file again, and then you commit it again, and so on and so forth. So at most of the time of your software process, you'll be basically doing this edit, stage, commit, maybe add file during the process. So I will come back to this file lifecycle slide many times throughout the demo, so you will be clear of what I'm doing. Okay. Okay. Now, why use Git of so many software? So Git provides a very complete long-term change history of every single file. And it logs changes in a very searchable way instead of renaming a file for each version. So I will, of course, everything will be in a demo for this one. And why use Git is one of the most important thing is branching and merging. So by branching and merging, everyone can work in parallel. You won't need to wait for this person to finish, then you could only do. And it can merge your changes automatically instead of the group leader having to manually compare the difference between each and every single file. So for this, the group leader is very mafan, right? Okay, and of course, the first two I talked already. And down is traceability. Understand why something is done and what was done. Of course, all of this I will show later on. And immutable. The most important thing is immutable. So it employs some mechanisms really similar to blockchain to prevent changes through the history. So it's nearly impossible to change the history of a Git tree. So the history is such important that if you screw up your code at any point, you just click and then you revert back to your version. Okay. Now, next is GitKraken. GitKraken is basically a GUI implementation for Git. So the one on the left here is a GitKraken GUI, which I will demo later on. The one on the right top here is called a Git timeline, where you can use that to track your project, a long-term project. Let's say you should finish this during this time, and have you finished? And what are the relevant commits towards this timeline? The one on the right down there, it's called a time. It's called bot. Sorry, it's called bot, where you can track issues. If you have used Trello before, yeah, it's something similar to that. So the GitKraken suite includes all these three tools, and yeah. So why GitKraken? Git is powerful, but it is very troublesome and time consuming to memorize the commands. You can see that the one on the left, on the right here, are actually commands that you send to Git for it to do what you want. So for here, Git clone, you clone the code down, and then you check out the branch, Git status, you see what is being changed. You add this thing into your README and everything, and then you check the status, see what is modified, you commit, and then you push with so many steps, and you need to type so many things. And if let's say I want some beginners to do this, it's very hard, and it maybe will scare a lot of people away. So GitKraken GUI provides a visual interface to enable this same workflow, but just with clicks. And of course, the most important thing is to visualize branches if you're working on a larger project. So of course, GitKraken is not the only tool. Right? Is the slide moving? Is my slide moving? Yep. Okay, alternatives to GitKraken. First is GitHub Desktop by GitHub, and all of this I won't talk one by one, but you guys can find it out at Git SCM download GUI. I sent the link there. So I've tested quite a few, and at the end I realized that GitKraken is the best, so that's why I chose GitKraken for the demo. Okay, so GitHub, and there's always a slight history about it. The right bottom down here is the GitHub mascot, the AutoCAD. So if GitHub throws you a 404 error, you will see this guy around. So GitHub launched in April 2008 and acquired by Microsoft on October 26, 2018 for 7.5 billion. So last year it had 40 million users and so many repositories. And it hosts all as an archive mirror of a significant number of fairly important projects. So it hosts Angular, TensorFlow, Bootstrap, MySQL, uBlock Origin, and it mirrors, so it serves as a copy of the Linux kernel and Git. So you'll host Git on GitHub. Okay. They also launched this thing called the GitHub Archive program, which is basically just copy your code and send it to the Arctic, and then just preserve there for future generations, just in case we get wiped off or anything. So some notable services on GitHub. Yeah, why my slide is progressing so slowly? Let me just redo my sharing. Sorry, guys. Now, where was I? Okay, so some notable services at GitHub. First is code hosting, where you put your code there. Documentation, it has a front page where if you do a readme.md, this file called readme.md, it will display on the front page. Wiki, if you want to have a more detailed documentation about your program. Discussions about the issues, your pull requests. Maybe you say, okay, I have this code. Do you want to add it to your code? And then you can submit a pull request. Or let's say your code has problem, then you submit an issue. And then it has graphs at Pulse contributors. This one I will show later on. It's very interesting. GitHub pages, where you can just directly host your website on GitHub. Gist, if you are familiar with Pastebin, Gist is basically a GitHub version of Pastebin. Security alerts, where it checks your code and see if there's any security problems with it, and sends you a report. And then GitHub Actions, you can trigger and say, okay, if there's a pull request on my code, what do? I compile it, I test it before sending it out. That's GitHub Actions. GitHub sponsors, if your program, your software project, let's say if your software project, you want someone to sponsor you, you just open this little tag called GitHub sponsors and people can start to sponsor you. So, okay, so as always, I will provide you guys alternatives to GitHub as Bitbucket, GitLab, SourceForge, Launchpad, blah, blah, blah. because why are people finding alternatives to GitHub is because Microsoft purchased GitHub. Yeah, so people are afraid that Microsoft will suddenly shut down GitHub and everything. So of all these alternatives, the interesting alternative will be this project called Readme. So Readme is basically a BitTorrent for code. Everyone is on the origin and everyone can contribute to the code. So it's a very interesting and a new concept there. Okay, so in conclusion, Git is the version control system. GitHub is the place to host your code, and GitKraken is the GUI interface for Git, basically the place you can click. Okay, so please don't mix between these. Okay, Git, I repeat, is the main system. It is command line. GitHub is the place to host your code, and GitKraken is your GUI. Okay. Again, I'll remind everyone, this is the Q&A session link here. I will repaste it again. Okay. Now, demo time. Hopefully, I don't break my computer or your computer in the process. Please do bear with me. It's my first time doing live demo, so yeah. Okay. So demo session housekeeping. So first, please still mute your microphone. You can't unmute anyways. So if let's say I'm too fast, send me a please slow down message to the chat area. I can't guarantee to respond due to a time constraint. If you can't chat, just raise your hand in Microsoft Teams and hopefully I will see it, I think. And then the agenda. Okay, first, we will create or fork a repository. And then later on, I'll talk a little bit about gitignore. And then I will clone the repository, or I will let you do a project using GitKraken and then push it to GitHub. It's almost the same. I will talk about both. And next, add a file to the local repo and then commit the change. I will be referring to the file lifecycle slide previously. Okay, and then of course push your changes to the main branch and make a change to your file with Git hosting tool and commit. Okay, and next, if let's say someone edited something, how do you pull the changes to your local machine and create a branch? If let's say you want a branch that replaces, let's say all of your images in your website with Hello Kitty, you can create a branch called Hello Kitty and just replace it. Okay, without affecting your actual branch, without affecting your actual code. So later on, we talk about pull request and merging. And as an extra, we will be talking a little bit about resolving Git conflicts. Okay, so for now, I'll share my screen. Okay, so you guys can see my screen, right? I think I'll pause for a minute or two for you guys to like switch on your computer just in case you haven't switch on, or just go to desktop. Okay. At the meantime, I'll take a look at the Q&A part. Guy from APU, Quang prefer Git CLI or GitKraken? Depends. If I do a normal project on my computer, I prefer GitKraken. If I do a remote project or if I do automation, of course, Git CLI. Okay, so prefer GitKraken definitely because it's GUI and I love GUI. Okay, so without further ado, I will first demo forking. Okay, forking. This thing is so laggy. Okay, so forking is basically saying that you want to copy their code into your repository. So you guys can follow me here. So just copy this link. I'll send it in the chat. Okay, I'll send it in the chat. So you guys just copy this code and then paste it in your browser. So laggy. Okay, so once everything is done, after you paste, you just go to the top right here, and you click fork. Okay. Now, once you fork, maybe they will ask where should you fork, because I'm a member of many organizations or many GitHub usernames, we can call it. So for me, I'll fork it to my personal one, and that's it. I copied the code. So for here, you can see that, okay, this branch is even with this master branch. So I know that, okay, now there's nothing to change here. Everything is the same. Okay, so next, let's start by cloning the code or creating a new GitHub repo. Wait, no, we clone the code first, sorry. So you click start and then open your GitKraken, okay? Sorry for the lag, guys. So after you go into GitKraken, if you are the first time signing in, you will see this, welcome to GitKraken. So I recommend you guys to click on the sign in with GitHub and then just sign in using your GitHub account. Okay, you just click sign in here, and then it will come out, and then it will ask you to continue authorization. So you just click confirm, next, everything, and you'll be signed in GitKraken. Okay, since I'm already signed in, I won't be doing this step. Okay, so to check whether you are really signed in or not, you go to the top right here, click on the preference, and click on profiles. And click on profile. Hey, no, sorry. Yep, integration, sorry. It's called integration. You click on integrations, then you click on GitHub, then make sure that over here is your account now, basically. Okay. You don't need to care about all of this for now, because let's just assume that you're working on a public repository. Okay. So exit preference, and then new tab. Okay. So after you open a new tab here, you can choose whether you want to open a repository or clone a repository or start a local repository that does not sync to any of the service. So for our case, we'll clone a repository here. Okay. So you have multiple options. You can click github.com here, and then it will find your repository here, and then you can click to clone. But for this demo, I will clone with URL. So how do you clone with URL? It's very easy. Just go up here, copy the code, copy the URL, and paste. Okay. It will then prompt you where it will clone to. So in most circumstances or default circumstances, you will be towards the folder that has the last the repository name, basically. Okay. So once you're done, just clone the repo. Okay. One thing to note when cloning a repo, right? So due to some firewall policies, I don't know if they lifted it now already. So previously, when I was at campus, UTeM campus, because they block SSH, so I think that time all my GitHub clones fail. So you need to take note of this and maybe switch to data or maybe use a VPN, I guess. So once it's successfully cloned, you click open now. So now you can see your repository here. Okay. So you have master branch, which in most conventions is called the main branch. We have branch A and we have branch B. So let's have a little familiarity with this interface. So undo means just undo what you have done. Redo, just redo what you have done. Fairly easy. Pull is, let's say you want to upgrade your code, or you want to pull the changes from GitHub, or we call it from the remote. You want to pull it down. So this is a pull. And we have multiple types of pull. We have a pull fast forward if possible, which means that, okay, if let's say there's nothing much to do about it, I'll just plug my branch and push it up. That's it. And fetch all, rebase. Rebase is another more complicated concept that I won't be touching today. But yeah, basically, in most cases, you just pull and fast forward if possible, and you'll be done. Push here basically means that you want to push your local changes through the remote. So in this case, remote is GitHub. Okay. So let me jump. Okay, now, so you have all of this code here. So where is it saved? So now let me open up where I save the code. So for normal cases, because I want everything to be organized and everything, I will put everything to this place called Git code, to this folder called Git code. So let me find it. So learn Git with GitKraken. So let me find it. Learn Git with GitKraken. Okay, it will be this folder. Okay. So for me personally, I use Visual Studio Code. You can of course choose any IDE you want, or even if you want to choose Notepad, also no problem. Because again, today's demo will only be touching on some really basic concepts about Git and will not touch about coding. Okay. So is everyone still okay with this speed? Those that are following the demo? You guys want to put a thumbs up or anything if you guys are following okay? Oh, someone is saying that my mouse does not have cursor. Okay, you guys can see my mouse now, right? Okay. Tell me if this cursor is too big. Okay. Now, once you do everything, go to index.html, this file here, and then scroll down to line 39 here. Okay. So you copy lines 40 to 48 here, and then from here, and then you paste down here. Okay. And then, well, you just edit. So the image, I'll just leave it as it is. H2 here, I'll say that it's me, Kwang. And then the paragraph, hi, my name is Kwang. Just for the sake of the demo. Okay. And then now I save it. So now, what am I doing here? Let me just get back to this file lifecycle. Okay. So for now, the file is already tracked. So previously when I pull it down, it's unmodified. After I edit the file, it became modified. And now, before I commit it, I will need to stage the file. So how do I stage the file? Staging, let me remind everyone, staging is just saying that, okay, I want to put this file in to commit. I haven't commit yet, but let me just put it in first. Okay, so you can click this index.html here, and then you can see what you change, what code you change here. So you can see this chunk you change. The red means you deleted this line. The green means you added this line. So Git, they compare line by line. So you cannot say that, okay, I just changed this letter and you want it to figure it out. It won't figure it out like this. It basically will figure out based on the line. So if this line changed, it assumes the whole line has changed. Okay. So now, once it's done, you can stage your file. Okay, you can click this to stage your file. Or if you are working on a fairly large project, you can also, on the left here, you can also click which line you want to stage. Let's say I just want to stage this line and I click. So I stage this line, I stage this line, I want to stage the other line. it's also very okay. There's no problem. Or GitKraken has this thing called hunk, H-U-N-K, hunk, that says that, okay, I want to stage this section that I think it's in one part. So you can stage hunk, just like this. Okay? Or let's say you want to stage this whole part, also no problem. Just highlight, right click, and stage selected line. Or you say that, oh no, I screw up this section, you just highlight, discard selection, and it's gone. Okay? Now, there are a few types of views in a GitKraken. So one is this, view via hunk, is this first one. The second one here is called inline view. So it will show you the whole file, and then where it changes, it will highlight it out. So the original file is here, everything remains, nothing changed, and you can see like this. Okay. And one more is split mode, where you can view the changes left and right. So left is your old code, right is your new code. So you just change this based on what you normally do. Okay. And this file will basically just views the whole file. There's nothing much. Okay. So now let's try to stage the changes for commit. Okay. So stage the file. So we put everything down here already. And then summary. So it's always a best practice to type a descriptive commit message. Don't try to type something like fix bug. That's it. Fix what bug? You need to say, okay, fix bug, maybe say fix image bug, or maybe change all images to Hello Kitty images, and so on. So there are some conventions based on which project you're working on. So for example, I'm working on this project, not me, but I've been joining. It's called Super Productivity Project. So in this project, because they use Angular, so you can see that, okay, the name is called feat, and then bracket taskbar. What it means is that this is a feature that adds into this thing called the taskbar. And this is the changes that it says blah, blah, blah here. Okay, now let's go back to our repo. So for now, so for the summary, probably I'll just write added my bio, just for the sake of example. Okay, and then you can commit the changes. Okay, now when you commit a change, it's locally. So if you want to push it to GitHub, you just click up here. It's called push. So click it, push. So it will now push to GitHub. And once it's done, it's done. Push successfully in master to origin. So if let's say, if let's say you want to create a new branch, and let's say, okay, this is you added your bio, but let's say you want to add someone else's bio. You can always come here. You can always create a new branch based on the commit. Okay, create a new branch based on the commit. So for example, I choose this commit here, which is before what my commit is. Okay, I right click here and say, okay, I want to create a branch here. So I create a branch that says, okay, second name change. Second name change. Okay, so now everything is checked out here. Okay, so let me check back my bio. What happens to my bio here? You see, everything here is missing now. Okay, sorry, everything here, line 50 is missing now. Because now I'm checking out the file version that is this space here. Remove testing from index here. I'm checking out this this particular commit. So everything will be based on this commit. Okay, so let me just recopy this again. And let's say this is called person 2. Okay, so person 2, and then the bio will be bio of person 2. Okay. Okay, now I save it. So if you are usually using Visual Studio Code, on the left here, it will show you this color here. Blue, it means that something has changed. Green means you have added something, and if you deleted something, it will be shown a little arrow there. indicating the place where you start to delete things. Okay, so now once you're done, of course, you commit again. And now I stage the change, I commit again, and I say added person to bio. Okay. Once it's done, same, I commit the changes, and then it's very fast. And then I push it. So now, because the origin at GitHub, they do not have this branch with this name called second name change. So therefore, I say, okay, which remote should this second name change branch push and pull from? Origin means GitHub in this case. And if you want a custom name, if you don't want a custom name, you just submit and let it push. Okay. So now, if let's say you want to incorporate your change, like let's say your team member has finished code or a feature within a branch, and you say, okay, now it's time to send this code to the group leader for checking. Okay, so what you usually do is that you open a pull request. So what a pull request means is that you request someone to pull your changes. So it's called a pull request. I request you to pull my changes into your code. That's why it's called a pull request. Okay. So to start a pull request, it's very easy. You just go to your branch here, click on these three dots here, or you can right click, and then you can click here and see start a pull request from origin into start a pull request from origin from this particular branch. So you click it and a GUI will pop up. So everything can be done within here. So you submit a pull request and second name change towards the branch master, and okay, now everything is like that. So you can add a title to your pull request, and let's say you added a person to bio and pull request description. Maybe you want to say, please accept my change, and then add a crying emoji to say that you desperately want the person to incorporate your change, and maybe add a ooh. Okay, so if you are working on a more advanced project, you can assign reviewers, like who to review your code, and assignees, who you are, you want to assign to who, and labels. So for most projects, you have this thing called labels, where you can like say, okay, this is a bug, that this is a pull request that fixes the bug, this is a pull request that adds documentation, and so on and so forth. Okay, so once it's done, you can create a pull request. Okay, this is one way to create a pull request using GitKraken. Okay, so you can create a pull request like this. Okay, done. So once you create a pull request, of course, you can view it on GitHub. Okay, so on GitHub here, you can see this pull request. Okay, this is your pull request number 1. You added this person to bio. Okay, now blah blah blah. You self-assign this. I assign this to myself, therefore it's called self-assign. So how a pull request is this, and everything probably looks good, and you'll see that this branch has conflicts that must be resolved. I'll be solving this in a moment. Okay, so in this pull request tab here, you can see that all of these requests that are open, or you can choose that it is not open, it is closed, and so on. So everything will be here. And if you want to submit a pull request, you can click new pull request here and just submit. So everything is in the GUI here. So now let's say I think that my code is fixes something, or I think my code is superior than what is originally there. Okay, so compare changes. I can compare the changes here and say that, okay, the base repository is this exhaust of where I initially forked my code from, and I want to merge to their master branch. And from where? From my repository, which I call the head repository, my master branch. Okay. Down here, you can see what you change. Also, red for deletion, green for addition. once everything is done, everything is the same, you just create a pull request. Just add everything you want here and create a pull request. So maybe sometimes you will feel that, okay, I'm not ready, I just want to draft this pull request. No problem. Just press this little arrow down here and create a draft pull request. Okay. So now back to our thing. Okay, now remember just now I said about it has a conflict there. Okay, so you can see a pull request on the left here, and it will be sorted out based on where which remote the pull request is targeted towards. Let's say Exosoft here has 3 pull requests. Okay, Origin here, which is my repository, has 1 pull request, which I did just now. So I can click and I say that, okay, now the branch has conflicts that must be resolved. So what are the conflicts that must be resolved? So a conflict happens when 2 files have different versions, but they will link, you want them to link towards each other. Like let's say within version A, the line on line 50 says that, okay, the number is 1, 2, 3. But on file B, the file says that, okay, the number is 4, 5, 6. Oh, sorry. So you have to decide which change from where to incorporate, or even to take both changes. Okay. So you added this bio, and now you have to review your changes. So view your file changes. Okay. So now you want to merge from this second name change here to your master branch here. Okay. So how do you do that? It's very easy. Just click on the second name change label here. Okay. And drag it onto the master label and just release. Okay. Now you can say that, okay, I want to merge. Okay, merge conflict detected, which is expected because I did it on purpose to show you on merge conflict. So to proceed with the merge, you must stash changes and check out branch master. Okay, do you want to do this now? Of course, yes. So I want to merge. Okay, now there's a file conflict, and now I want to see what is happening here. Okay, so I click in and say that, okay, now GitKraken shows me that I have this tool here. You can see that on version A, it says that the code looks like this. On version B, it says that the code looks like this. So which one should I take? For example, if let's say I want to replace everything from version A, I just click the little tick, the little checkbox up here. I can see that, okay, the output is like this. And basically the merge conflict is done because I select everything. Or I can even do and say, okay, I want line 44 from file A, and I want line 45 from file B, line 46 from file A, line 47 from file B, and so on. So for GitKraken, because it's a GUI, you can easily click and select like this. Okay, so it's quite fun, but hopefully you won't encounter this during your merge because it's quite annoying, to be honest. Okay, now let's say we want everything from file B. Okay, so you can see that everything from file B, and I cherry pick 2 lines from file A. So I say that, okay, 44, 45, I selected it, so it will now be up here. Okay, let's just do it for the sake of the example. Okay, let's do it for the sake of example. Okay, so everything is done, and then when everything is done, angels sing and the light fills the room. You can say, okay, so when everything is done, you can merge branch. So you just commit and merge, and you pat yourself on the back and say that you settled a merge conflict. Yay! Okay, so we've settled about merge conflict and everything here. Let me see my slide. What have I haven't done? Yeah, there's 100 slides here. You guys even feel it, right? There's 100 slides actually. Okay, now let me just go back to the agenda. So we created we forked the repository, and of course we copied it down also. Okay, this gitignore I haven't tell you yet. I will tell you later. We copied the repository to the local machine just now by just clicking, paste it in, select the folder, and close. And we also added a file to our local repo and just commit the changes. Is that easy, right? And then we just push our changes to our master branch, and we make a change to our file and committed it. Okay, it's that easy. And we also pull some changes to our local machines. Oh, okay, we haven't done that yet. Okay, so what about pulling changes? Let's say if someone edited their code, or let's say your team members, okay, edited the code, and then you want the code to be in your computer. Okay, so let me open GitKraken again. So if you have an origin, you can choose to pull, but when you pull here, what you're doing is that, okay, now I want to pull what is currently on master to my computer. Okay, let me just demo that. Okay, so now I have did some changes just now and I haven't pushed it, so let me push it for now. Okay, I pushed it. So now I open my remote here, and then I say that, okay, I want to view it on GitHub. So GitHub is here. And for example, I want to edit my index.html file here. Okay. So I click it. And then, of course, it is not a good practice to do this. Let me just tell you guys again, don't do this unless you really know what you're doing, because it will screw up the formatting. Yeah, GitHub does not have built-in formatting, so don't do this at in normal circumstances. Okay, so for these circumstances, just for you guys, I'll break this. Okay, now, okay, let's say I'll edit this line. Okay, now this line is called edit on GitHub. Okay, so I edited this line 45 here. I edit it on GitHub. Okay, now when everything is done, it's the same. I commit the change here. Okay, now this change is called update index.html. You can use it by default. And then you can say, okay, edited something, or you can just don't touch anything about it. It's not really a good practice, but let's just do it for the sake of it. Okay, so now commit changes. Now, when you commit changes, you are now on the latest version here. See, the latest is here. You updated index.html, and this is your commit hash. So this commit hash is a unique, and probably in the whole world, only you have this commit hash. So every commit is special. Okay, treat every commit equally. Let's say. Okay, now you can see when I update index.html, it's reflected here on GitKraken already. I think right. Okay, so it's reflected on GitKraken already. So you can see that the master here has the icon. This icon is my GitHub avatar icon or your profile icon. Okay, this master here has a little computer. It means that it's on locally. It's on my local machine. So what I do now is that I pull in changes that is currently on GitHub. Okay, so now I pull, and it will fast forward if it's possible. So now it fast forward. See, so you can see now the version at GitHub is the same with the version on my computer, and it is true. If I go to index.html here, I can see that, okay, I can see this edit on GitHub, this thing here. Okay. Now, let's say you are working on a very large project, or maybe you realize that sometimes GitKraken does not update quick enough. What do? You do this thing called a fetch. Okay, it's called a fetch. So from where you want to fetch? So it's a remote here, it's origin, and then of course the three dots here, or you can right click, and then you can see fetch origin, which means that you are pulling down the changes from GitHub for you to look without changing your local code. Okay, let me repeat. Fetch meaning that you pull down the changes from GitHub without changing your local code. It's just saying that, okay, I have this thing. Let me see if super productivity has it. Okay, now I try the fetch. If this guy changes anything, then it will be up there. Nope, apparently does not have. So yeah, patch is basically just saying that I want this latest version from GitHub. I want everything down. Don't touch my code yet. Okay, this is patch. Pull means I pull down the latest change, the branch that is corresponding to my master branch. I want it to pass forward if possible. I pull the changes, and if possible, I want to pass forward it to update my code to the latest version. Okay. Okay. So that's a pull. So branch, just now I talked about it already. So a branch can be very long, or no problem, it can be short. It can be a single commit. It can be a single commit branch. If you're a more advanced Git user, for those kind of branches, I would recommend a rebase. Okay, you can search it out by yourself. I recommend a rebase. For long branches, I would recommend using merge. Okay, using its own branch, then later on merge to the original code. So why did I choose GitKraken is because it's very easy to visualize how the code progress and how the merge goes. So for example here, look at this commit here, remove testing from index, okay? So from here, I can see that, okay, this commit added my bio here, branches from this commit here, and added person to bio also comes from remove testing from index here. And both of these merge at up here. So from at here, what did I merge? I merged these two commit to this new commit, and my code continue from here. So maybe you won't feel, yeah, this one small thing only, ma. But what if, yeah, this is my own project, I think. Yeah, you can see that, okay, like let's say if I shifted the code and everything, and I say, okay, I want to try a new version here. So I shift, and then everything is here, and then I merge it in. So for larger projects, you guys can still see my screen, right? Yeah, okay. So for larger projects, something like branching will be very useful. Okay. For projects like the Linux kernel project or some large projects like Kubernetes, these branches actually go to the number of thousands. So at any time, there will be probably thousands of branches at the same time. So Git was designed to handle this in mind. So you won't have to worry on your normal circumstances what happens. Like you won't break it, basically, unless other than the merge conflict, you won't break it. Okay. So next, we created a branch. We made a change. We committed the change. Okay. We opened a pull request just now. We proposed changes to the master branch. We also merge our branches to the master branch, and we resolve Git conflict just now. Okay. So everything is done. And now I will talk about how to initiate a project. Because just now, what we are doing is we are forking code from other people. Basically, we are just copying their code. Okay. So what do we do when we want to create a new project? It's very easy in GitKraken. Okay. In GitHub, it's also fairly easy, but let me just demo it using GitKraken. Okay. Now, you just open a new tab as usual. And over here, you can choose to start a hosted repo. For me personally, I would recommend you guys to start a hosted repo. Why? Because if there's anything happening to your computer, if your computer kena virus or kena ransomware, you won't need to be afraid at all. You just copy everything down from GitHub, and that's it. Okay, GitHub is free for all software projects, for all repositories. So you can do a private repo or a public repo. So a private repo means that only you and a select contributors can see it. A public repo means that anyone can see it, anyone can fork it. Okay. Now, for GitKraken, if you are using a normal version, they don't allow for a private repo. Why? Because this is where they earn money, basically. Yeah, they also need to earn money to sustain, right? But if you are a student, you can go and request for the GitHub Student Developer Pack to get a free GitKraken. If I remember correctly, throughout your academic time. Okay, so now if you want to start a repo, it's very easy. To start a hosted repo, you just over here, you just click here. For me, of course, GitHub for the bin. I click it and I say, okay, I want to initialize this repo at GitHub. And then I select my account and the name. Okay, maybe this name is called a random repo demo. Okay, description is let's say random demo repo that I did for demo for DSC activity, for example. Okay, now access public or private, like I said just now. Sorry, clone after init. So clone after init, it says that okay, after you initialize, you do a copy on your machine. You don't have to pull it down again. So clone after init. Okay, where to clone to? So where to store your folder, where to store your code and everything, and your full path. Okay, default branch name, you can call it main, you can call it master, you can call it Gosujin Sama, also no problem. And next is the quite important one. It's called a gitignore template. So when you produce your code, there are a lot of useless code or stuff that you won't want to commit in your normal branch. Like what? If let's say you are using Angular or using TypeScript, you won't want your compiled HTML and JavaScript file to be present in your GitHub repository, because this thing can change anytime and it's very easy to regenerate it. Or let's say if you're coding in C++, you definitely won't want your object files or your executable files to be committed in, right? Because remember, in Git, all binaries will be done. All binaries or all files will be tracked by copying. So if let's say your executable file is 1 GB in size, after 5 commits, your repository will grow to 5 GB. Okay, so do not commit binaries unless absolutely necessary or unless this whole thing does not change at all or does not change frequently. Okay, so this gitignore template, GitKraken provides yeah, someone said it. Okay, so GitKraken, they provide you a gitignore template here. So over here you can just click what you're doing. So for now, maybe I'm doing a node project. So I just click node and the gitignore file for that thing will be generated automatically. Or let's say I'm doing Unreal Engine. I can just click Unreal Engine and it will initialize for me. Or let's say if you're doing in C++, or C++ can have C++. Yeah, there you go. Okay, so it depends on what you're doing, but for this, I'll just do node. Okay, so license. What license you want to do? Optional, but you can always do copyright, your year, your name. Okay, usually for my projects, I will put the MIT license. For more details on licensing, you can go to, if I remember correctly, it's called choosealicense.org. For there to look on all of the license and everything. But if your project is not of very important, right? If you're just a normal project, right? Just put anything you like, lah. Okay. Now initialize with LFS. In most circumstances, you won't use this. GitHub only provides 5 GB of LFS for normal users. So LFS is basically an object storage for you to place different versions of your binaries. So remember just now I said Git does not really support binaries. So LFS, they provide something similar. They provide this service, versioning of binaries, by doing pointers towards the hosted version. Okay. So once everything is done, you just create the repository and close. So just wait for a moment and it's done. This is your repository. So remember I said just now about gitignore licensing everything. So same, I open folder. Now where is it? What's the name again? The name is called random repo demo repository. Okay. So random repo demo. Okay, I open it, and now there are few stuff here. So first is a Readme. Readme is basically a file where it shows at the root of your repository. So let's say this random repo demo, and I say, okay, Readme. So I'm writing in Markdown format. So Markdown is basically a very simple format for you to format your documentation and so on. So you can see this little hash at the front means that I want it to be big, and then a readme. See, it will be smaller here. And then of course I can auto format it. And then let's say I want a small readme, it'll be like this, and so on. Okay. For more information, refer to the respective documentations. Okay. This one is just a little demo for you guys. And then okay, next is licensing. So because I didn't choose any license, it will be just shown like this. This is my copyright. This is my code. Copyright. That's it. Okay. Now the more important thing, gitignore. So gitignore is basically a file that says that okay, Git, do not touch this file. Do not stage this file. Do not commit this file. Or like do not put anything like do not put all these files to this pending changes, or do not stage it, do not touch anything on this file. Why? Because I don't want it. So in best practices, put those generated files in gitignore. So like I said, for example, if you are doing logging.log, usually people don't commit it because it's device specific. And let's say I don't want to do types because the declaration files is not important. I don't want to include a node modules because I can easily npm install it and install it back. So I don't want to do all this. So this gitignore also refer to the respective documentation for details on how to use this file. Okay. Now next, what do I left? Okay, yeah, stashing. Okay, so you have done all these changes and said that okay, probably I want to check this commit by other people. I don't want to commit my code yet. So what do? I stash. So stash means that I put this code, I tapao it, and I just put it aside. So you can see I click stash here, and it just tapao it here. And then I just do any changes here again. Let's say, so you can see that once I tapao it, it reverts back because I tapao it already. So now I do something again. Readme 2. Okay, readme 2. Okay, so now you can see that it basically comes up as a new thing here. Okay, so this is stash. So what if you don't want what if you say that okay, I want this code to be applied on top now. So you can pop it. Remember during your programming, you learn about queuing and popping. So this is one thing. You pop based on the one on top. You pop it up and you apply the changes on your code. So you have uncommitted changes and you should not apply. So this sometimes will be a destructive operation. So please be careful and make sure that your branch is clean. So what do I mean when the branch is clean is that the code, you don't have any pending changes. This is called the branch is clean. So in most cases, best practice, make sure that your branch is clean before popping the stash. But just for the sake of it, I'll pop it. So see, it has conflict here already. So what do I do is that I probably undo this. Okay. So now it goes back to the initial commit and I can push. Or I can just do this. Okay, now I have changes here. Or I can straight away click here and I can just click this little dustbin here to discard all changes. So I can reset the changes to down here. And now I can safely pop it up. And that's it. My changes are back in. Okay. So I'll take a look at the questions and see if there's anything. Okay, so I think that concludes our Q&A session. And sorry, a demo session. So everyone is okay? If everyone is okay, just put a like everything. If it's not okay, just go to the Q&A section there and ask. Okay, now I will talk a little bit about best practices, or basically just what to do and what not to do. Okay, because Git, again, it's a really powerful tool. So if I don't give this, then I'll be giving you guys a really, really sharp knife and don't tell you how to use it. So you'll probably hurt yourself in the process. Okay, so best practices. So one, for team leads, I recommend you guys to lay out the boilerplate code for your team members for them to base their work off on. Unless everyone uses a different file, then it's a different story. But in normal cases, let's say C++, your C++ development is a Visual Studio. So your group leader should create a project and maybe put some functions and the function names in there and send the group members for editing, or maybe just reserve spaces for those functions and send them to edit. Okay. And second is to format code before committing. Why? Because if you don't format code, people will probably format code on their devices, and those formatted code will be counted into their commit. So if you don't format code properly, you will probably be very hard to track changes that happen. Okay. Third is pick your stage code commit every now and then. Pick your stage code and then commit every now and then. So your committed code on best practice should be directly workable. So let's say your commit and says, okay, I do this. So the whole thing must compile. Let's say if it's C++, the whole thing must compile. I don't care if that thing has logic errors or not, but it must compile. This is the best practice of Git and committing. So pick your stage code every now and then is that you don't commit all of the changes at once. You pick based on the commit messages. Like let's say you add a message here. You added a message in the program and said, okay, I add this message function, commit, and then I add the message thing, the message thing in there, and then I commit. Okay. And fourth is use commit messages that make sense and keep up to date your branch. Okay. Don't do something like toxic. Okay. Now, don't. Number one, commit binaries that are large, host to frequently change and easily downloaded. Don't do that. Okay. And don't commit generated files. In general, don't alter history unless you have a really good reason to do so, because if you alter history, you risk erasing changes by your team members and probably sabotaging their code at the process. So don't do that unless you have a really, really good reason to do so and you understand Git enough. Then you only do it. Okay? And this applies together with force push. Don't force push unless you know what you are doing, because as always, you will risk wiping out history and your progress. Maybe your group member will say that, hey, I committed this code, why suddenly disappear already? This is the result of force pushing. Okay. Don't commit secret. So unless it's just an assignment. So secrets are basically like passwords of your file or maybe some keys towards some API. So unless it's just an assignment that maybe just send for maybe a few weeks or a month or so, don't commit it. Do a separate called a .env file where you put all your secrets in there and don't commit that. Okay. And most importantly, when using Git, don't panic. Okay. Don't panic. Because once you panic, like what I did last time, the whole repository goes haywire. So don't panic. Take a deep breath and ask yourself what you are doing. Okay. If you are feeling you are almost panicking. Okay. Now, Git flow. Git flow is just this basically this very common idea of developing. So we have a stable branch, which is the master, develop, and release. So these branches are called stable because on most of the times, it will stay in a project. So master branch is the main branch, develop is maybe for the next version, and release is maybe some little stuff there. And volatile branches will be features and hot fixes. So why we call it volatile branches? Because maybe you see this branch here today, tomorrow the branch disappeared because it's being merged already. Okay, that's why we call it a volatile branches. This thing will be more suitable for larger teams. So let's say if your team has 2 or 3 people, you probably don't need it, but maybe 5 or above, then you will probably need it. And if your project is big enough, okay? If your project is so small, you no need to do this. Just do everything as a volatile branch, and that's it. Okay. So best practice for team leaders, like I said just now, do boilerplate code. And next is protect the main master branch. So at most circumstances, don't let your team members directly push to the main or master branch. Don't let them do that. Okay. don't let them commit unless necessary. Okay, so now I will demo a little bit about how to protect your main branch. Okay, so remember just now we did this learn Git is GitKraken here. Okay, now you can do this settings. Okay, go to the settings and you go to, if I remember correctly, security and analysis. No, sorry. It's called branches. Yeah. Okay, so now it has a default branch. It's a base branch, and I can say that I want a branch protection rule. Okay, so I say that, okay, this branch I don't want force pushing. I don't want this branch to be accidentally deleted and have status checks before merging. Okay, so now I copy this branch name. I add a rule. Add a rule and say, okay, what is this branch name pattern? Okay, the branch name pattern here is called master. But if you know regex, this is the branch name pattern that you can put it in. Okay, so now to protect the branches, everything, you can click here, and then you just create. Okay, so if let's say someone want to force push to your branch, you can prevent that. Okay, so for example, let's say I create this branch. Let me try if I can force push it. So my password, because it's a very important thing. So now it applies to this branch. Okay, now let me try. Then Git GitKraken. Okay, now I want to revert my changes here. So now, let's say I want my change to be here. So here, right click, I check out this commit. So this head means that my current situation is here. I'm at here, my file is here. So what I do now is I rebase it. Okay, is it correct? Oh, sorry. Okay, that's it. Okay. Sorry. Okay, right click, reset master to this commit, and then I discard the changes and then I push it. So you can see that, okay, now my master at my computer is behind what is at GitHub. So what do I do? So in best practices is that you pull it, then you update it. But no, I don't want to do that. So I just force push it. So of course it will warn you again. And of course, that's what I do. I force push it. It should not let me force push. Yeah. So you see, protected branch hook decline. So it does not let me force push. So for your team leaders, do this for your repository to prevent team members or those people that don't really know how to use Git from actually accidentally destroying your main branch. Okay. Now, and next is use Discord or webhook to receive notifications about changes. This is what I love about Discord. You just use a webhook, and let's say if there's any change, you will receive a Discord notification. So how do you do that? So in Discord, it's fairly simple to create a channel. So you just create a server, and then you create a channel. After you create a channel, you just add a channel, and within your channel, you just do this edit. Then you can click on integrations, okay, and then webhooks here, and then you copy the webhook URL. Oh, okay. So you just click this, copy webhook URL, and then in your GitHub here, let me just remove this this protection. Delete the protection. Okay, now in the webhooks here, I click, and then I add a webhook. Okay, and then I paste it in. I paste the whole thing here, and then I add this thing called /GitHub. So what happens is that anything that there's any changes or everything, you'll push the notification to my GitHub. Okay, so content type JSON and send me everything. Okay, if everything is okay, you'll be a green tick here. So let's test it out. Remember this thing here? Okay, now this is what I've been doing now. So yeah, so let's see where is the changes. Take a look here. IAS main is the last thing here. So let me force push it again. This time it should Okay, never mind. I'll undo it. And then I'll commit this thing, stage everything. Sorry. Let's do this. Okay, let's say I delete this part. Okay, save it. Okay, now I have something unstaged here. I stage it, and now I say, okay, demo push, demo webhook. Okay, let's call this commit demo webhook, and I commit it. So because I haven't pushed it to GitHub, it's still here. You won't receive any notification at Discord here. So let me see if I can. This R. Okay. So now once you push, you can see, you can look at here. Once you push it, once GitHub receives notification, everything, and oh, it's here. Sorry. Yeah, it's here. See? So this is how you keep track. Let's say if your team member is, or actually if anyone is doing anything, or if anyone opened a new pull request. So this is a really useful way to let you remind, or you don't need to keep on looking and asking your team members and everything. You just take a look at your Discord channel, and that's it. Okay. Now, this is for team leaders. Okay, for team members, of course, team leaders are also team members. So always, when any feature you do, always branch from the latest version of code. This applies for when you're doing assignments, okay? Because everyone is going very fast. So always branch from the latest version of the code, then only make changes based on it. So if possible, before you submit a pull request, you merge the latest changes first, then only submit the pull request. So to reduce the potential potential happening of a conflict. Okay, so of course, best practices, one branch, one feature. If let's say you are waiting for a group leader to merge your code, you always progress by making a new branch based on the latest code. Okay, always make a new branch for each feature. So your group leader can say that, okay, I pick this branch, I merge it, I pick this, I merge it. So it reduces your group leader's effort on doing it. Okay. Now, next is of course always format your code before committing, or you will risk your contribution being taken away. How is this? Later on. Okay. I will talk a little bit about it. So, if let's say under likely or unlikely circumstances you screw up your code, and you don't know what is the problem, Git, very easy. Delete everything locally, download or Git code everything down from GitHub, done. Okay, that's it. So in some upcoming sessions, we will talk a little bit about VMs and containers that enables you to do the same stuff in a better way. So I'll be a little quick because I think we're running short of time. Next is GitHub as portfolio. So many companies, they take GitHub as a portfolio, like basically a place to showcase your work. So in GitHub, you can basically pin the projects that you're most proud of at your profile page. Okay, so it also has this thing called an activity analysis, and let's say how many contributions in the last year, and within the last year, what is your activity consists of, how many commits, pull requests, and how active you are throughout the day. Also, you can do this thing called a GitHub front page, where you create a repository that is your username, and then you create a file called readme.md, and then you can have a really cool front page like this. Okay, I'm not a fan of Microsoft Edge, but this is what I found. Okay, now to the best part of Git, making sure your teammate contribute. Okay, as a contributing member, we hate sleeping members, right? So by using Git, we can prevent sleeping members. How? Okay, we can go to the contributors tab or the network graph. So let me just show you. So this repo is too small. Let me open another repository that is relatively slightly larger. It's called super productivity, like I said just now. Okay, so in your repository here, up there are many tabs. There's one tab called Insights. Click on it. And from here, you can see contributors. Okay. Now, over here, you can choose how do you want to count the contributions on. Okay, so for me, you can count based on commits, and I say, okay, now this person, how many lines of code he added, how many lines he deleted. So from here, how many commits he put in, and so on. So from here, it's actually a nice history of who did what when. Okay, if let's say you want to narrow down, you just highlight this place, and from here you can see that, okay, for this point in time, this guy contributed this much over this time. Okay, so from here, if let's say you have a team member that does not contribute at all, just screenshot this page, send to your lecturer, and report the shit out of them. Okay, sorry. Okay, now we have graph contributors and of course a network graph. So network graph, it's a timeline thing that shows you the most recently pushed fork. Okay, this is quite a big repository, so let it load for a moment. Okay, so for now you can see that, okay, the last month who committed when? Okay, June 1st. Okay, who committed what, when, on which branch? Okay, it's kind of similar to what GitKraken has here, but this thing is in GitHub. That's the only difference. Okay. I think, yep. Okay. Now, I think to the latest, almost the last already. So, Git Blame. If your code screws up, you now know who to blame. Okay. That's why it's called Git Blame. Okay. Same within GitKraken. Let's say I want super productivity, because this is an ongoing project. Okay, now let's say I want to know who edited this. Let's say this file called task electron effect blah blah blah. Okay, I click it, and I can see this, and then up here you can see this thing called blame. Okay, click it, and you can see the history here. Okay, the history of this file, you can see everything is here, and you can just go back to the version by clicking, and you can jump around. So what makes this feature so important is that it highlights which part of code is added when and added by who. So this guy here is Johannes, is the lead of this application, so he adds the most of the things. So from here, you can have a nice view of what is happening when and when it happened. So you can see the thing here. Okay, you can see this is my authoring here. You can see that, okay, if this line goes wrong, blame me. Yeah, that's it. Okay, now go back to the slide. That's it about Git Blame. Okay, yeah, sorry, it's a really long session. Now, takeaway points. I'll be really quick on this. Okay, Git solves many software development problems by providing you a distributed version control service. Okay, Git is the version control software, where GitHub is the code hosting website, GitKraken is the Git UI. Terminology: a repository means a place where you store code. Remote repository means a place that is not on your computer. A branch means a movable reference to a series of commits, or you can think of the main trunk here, and you branch everything out. You can think of it as, like that, as a branch. And a commit is a snapshot of your code at that point of time. Fork, basically copying other people's repository. A gitignore is a file that tells you what not to track. Okay, it relies, I think, on regex, if I remember correctly. So do look that up for the documentation. Pull request is you request others to pull your changes. Okay, to pull your changes in. And stash is a temporary place to store your code, just in case you don't want to commit it in. Okay, Git file workflow, to track files, stage it. You commit the file to make a snapshot of it, and then stage your changes to prepare it to being committed, to untrack it, remove the file. Okay, everything that I demoed just now. Okay, now thank you guys. for joining. This will be our second session of the DevOps series, Git, GitHub, and GitKraken. So for the rest of the series, I think it will be at least 3 or 4 weeks later because we have FYP and we have final exams. So it will be later on, but I promise everything will be here. And okay, some public service announcements. I'll be really, really quick on this because yeah, I think it's useful for everyone. Okay, now free stuff. Just because you are a student. So as a student, you can get a GitHub Student Developer Pack. For more information, just go to educationgithub.com pack offers. I sent the link there. Okay, and of course, if you are a UTeM student, you can have this DevTools for teaching. Okay, this DevTools for teaching is place where you can get free Windows 10 licenses, free Windows Server licenses, and so on and so forth. It's quite a lot of things there. Free Microsoft Visual is also there. Okay, so do check that out. For other universities, I'm not that sure if you have that or not, because yeah, why I'm introducing this because Malaysians, we love free stuff, and because well, even our government vaccine website is running on free tier software, but okay, next is GitCon. Virtual conference for the Git community. If you are interested, okay, gitcon.com. It's hosted by the company that created GitHub, and that created GitKraken. Link is in the chat also. And next is Industry Insights by ICMS. So this one I won't talk much about it. I will just say it's a very interesting place for you to go and explore, present yourself to headhunters of many companies and so on. Okay, slides will be shared so you can take a look later on. Okay, this one is just in today. It's Google for Games Developer Summit. So if you are a game developer or if you're studying BITE, then probably this event is for you. It's an online event that basically teaches you how to use Google technologies to make your game more sustainable, to make your games scale up. Okay, so you can register at the link there. Okay. Now the next one, DevOps Academy. This one, you can just take a look at our Facebook page. We did post something about it, so I won't talk much about it. Basically, I'll also recommend this because it's a program that has a lot of great people in there that will teach you on computer science. Yeah, we have one of the heads of the AWS user group teaching there. So yeah, you know so how big is it? Huh? Okay, and next is a request for proposals. Okay, if let's say you have something you want to share, you have a short talk, you want to give a full day workshop, it can be anything. Okay, something you found out or some hack, can be hacking a website, ethical hacking, hacking a website, how to reverse engineer a website, no problem. You just submit this in the request for proposals form that I sent it there. Later on, I will put it on our Facebook page also. And anyone can apply this. You can be a student, you can be a lecturer, alumni, even if you're an industry expert, I'll be honored to have you here. Okay. The link is here. I've sent it in the chat. And do follow us on our Facebook, Instagram, LinkedIn, Discord, and in our Facebook group. Everything is in the link. Everything is in the chat box, so I'll just skip it. Okay, now Q&A session. So I think I'll just end this session first, and then we'll proceed to Q&A, okay? Okay, yeah, before I end, references. So if you want to understand more about Git, you can look at this book. It's called Pro Git. It's a 500-page book about Git, and it's hosted on GitHub. You don't need to finish it, but even by reading the first 20 pages, you will learn a lot already. Okay. Next is further resources. Learn Git branching. If you still don't understand much about Git in general or the branching thing in general, you can just learn it here. Okay. So you can just type the Git commands here, and then it will give you a really good visualization about Git and how it processes your thing. And of course, the next thing is learn Git by Atlassian, which is one of the reference I did, and where the nice graphics in this slide come from. Some of it. Okay. event feedback form, if you want, please fill in this feedback form so I will know where to improve during this thing. Okay, and that's it for the session. So yeah, so if you want to leave, you can leave now. Thank you everyone for joining. Please do fill up the feedback form there. If you want to leave, you can leave now. If you want to join the Q&A session, you can also join, or you can leave anytime during the Q&A session there. Okay, and I will based on how many people are left after the Q&A session to decide if I want to do the extra section. I have a short extra section later on if you guys are interested. Okay, so if you want to leave, you can leave now. I will answer the Q&A session now. Okay, so let's say my teammates don't know GitKraken and we want to learn GitKraken as ASAP. Which resource do you prefer the most? Okay, for the resource, GitKraken actually provides a really good documentation. Okay, so GitKraken has its own documentation. You can see it in gitkraken.com. Over here it's in Learn. So over here, education resource, student resources. Even some of my slides are based over their stuff. Okay, so over here you can take a look. Here are the videos. There are lots of videos here. But on most cases, right, you will only need to learn the beginner and maybe some of intermediate. You will need to learn advanced here. Because for me personally, I don't even use the stuff in advanced. Okay, so this is one. If you want everything to be in GUI and you want everything to be based off GitKraken, this is where you learn it. Or like just now what I said, you can learn it from the Atlassian GitHub. Yeah, let me copy the link. Atlassian Learn Git website. It's here. Okay, so there are many tutorials here, from how to install Git, to how to start Git, or even how to host your Git server. Sometimes some of it. So you can just based on maybe you can do until collaborating here is enough. It's enough for our assignment use cases. Okay, I hope that answered your question. Okay. Okay, UTeM student using UTeM email also cannot chat. I don't know. Sorry. I really don't know. Okay. I'll try to fix it later on. This one I really don't know. I will test it. Okay, where's my mouse? Okay. When did you learn this GitKraken in detail? Yeah, like what I shared just now. Okay. Like what I shared just now. Most of the stuff is learned there. Okay. Guy from APU, Quang prefer Git CLI or GitKraken? Prefer GitKraken because it's nice. Because it's GUI and can easily visualize everything. Can I fork anyone's code? What is the purpose of forking when I can just CMP? What's CMP? I'll put this. CMP is copy and paste, by the way. Okay. When you fork all of their changes also. Like, let's say this project has been going on for, let's say, 1 year. So when you fork, you essentially copy the whole history also. Okay. The reason for doing that is because it is more easier to track back, and maybe at most circumstances you can understand why this code is where it is. Okay. And to commit to Git or GitHub, you must fork the code. Okay. For more details, of course, it's in the extra section. It's in the extra session. From there, you will understand why you need to fork and why not just copy and paste. When you copy and paste, it's basically you just copy this current snapshot, this section, and that's it. Okay, there's no history. So the reason for forking is you want the history and you want to commit also. Okay, if you just want to run, copy it, no problem. Okay. Let me fix this. Yeah, so down there, so fork is duplicate folder in Git, right? basically duplicate the folder together with its history. We're going to put it that way. Also, why does my GitKraken say the trial end in 6 days? How do I use it for free? Sign up at use the GitHub student tag to sign up. Okay, use your UTeM email, link it there. So the details is you can go find it, the GitHub documentation. Everything is being set there. You can just go there and take a look. Yeah, let me take it. Okay, I get a warning from creating webhook on GitHub. It tells me my last delivery was not successful. Invalid HTTP response. I think the reason is the wrong URL. So remember, you copy the webhook URL. For example, the webhook URL is, okay, for example, is this. So remember, when after you copy the URL, add a slash and add GitHub. Okay, do it like this. Add a slash and add GitHub. And the type of the format should be JSON. Okay, so depending on my mood, maybe later on I will create a little workshop on how to use a Discord webhook. Hopefully, I don't know. Okay, let me take this. I didn't have any chat space. Yeah, sorry about that. Okay, gitignore.io for random sharing for gitignore collection. Yeah, please. Yeah, sorry. Yeah, please. You can check that out too. Let me just copy it and paste it in the chat box for anyone interested. Okay, I have a Python coding project that uses Tesseract OCR, but I can't put the OCR file in GitHub because the file is too big. How can people demo my code? Okay, so for my use case, I would usually make a script called setup.sh. Let me open a live code for you, the actual code. Okay, now, sorry, I need to close all the code. Okay, so during running, okay, so you guys, yeah, okay, sorry, because I, oh no, okay, I will need to change the link later on. Hopefully, you guys can copy the link. Okay, now what do I do is that for binaries and everything, I would download it from an external place after setup. So let's say after I git clone everything here, I will create a script called setup.sh that's already in my repository. So after I git clone, I just run this setup. So for this case, what the setup script do is that it imports this, it imports the gdown, this thing, and then it checks if this thing has installed, and then it downloads it. Okay. So for my circumstance, I use Google Drive as my hosting, and then when it's running, it will download everything in. Okay, it will download the TensorFlow wheel, it will download the model, and so on. Okay, so this is for large binaries. Hope that answered your question. So you need to tell them, okay, before you demo, you run this script. Or, okay, you copy everything in. Wait, sorry. Okay, write a script to copy everything in. Or you can say that, okay, to run this program, just run this script. And it'll automatically download everything together with all the codes, and you'll compile, blah, 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 and that's it. Okay. Okay, now let me just fix this thing. Okay, so please send us an attendance link. I'm not the level at sir yet. Don't call me sir. Okay. Hopeless coder. I completely lost my interest in become a programmer. I find it no longer interesting for me. Come on lah. How can I gain my interest back? I would say to do projects. For me personally, I like to break things. So at some project, okay, for me, I also will have burnout sometimes. So for me to gain my interest back, I will find some things to correct. And let's say there's a problem in this system. So I will maybe correct the system and maybe write a script to maybe scrape all the data from that system. Maybe. Okay, this is just maybe, yeah. Yeah. So do something or maybe find a problem to solve. Okay, just look around. Okay, yeah. I think that answered your question, hopefully. I don't know you're trolling me or you're really asking me, but yeah. Okay, which year of degree is Quang now? Year 3. Yeah, I'm in year 3. Just wanted to say thank you. Thank you for joining too. Okay, thank you everyone for joining. And I think that marks the last of our Q&A session. So thank you guys for joining in again. The slides will be shared later on, and the recording will also be shared later on. So thank you guys for joining. If you want, you guys can follow me on GitHub at github.com/pongpn. And we'll be doing the extra session in about 3 minutes or so. Yeah, just let me get some water first. I've been speaking nonstop for 2 hours. Okay. So thank you everyone for joining. If you want to leave, you can leave now. Or if you want some little extras, you can just stay back. So 3 minutes break. Thank you guys. Oh. Everyone, and sorry. Welcome back. So welcome to the extras of Git and GitHub GitKraken session, where more technical stuff will be coming in. Okay, so if okay, please give me a thumbs up to indicate that you are still awake. Oh, okay. Okay, now just a little heads up, this will be quite technical. So yeah, please bear with me. Of course, if you want, you can leave anytime because this is an extra session. Okay, now let's talk a little bit about how Git works, like a little bit behind the scene, okay, and technically. And later on, I would let you guys take a look on the actual stuff. Okay, now some ideas. So first, Git at its base is a content addressable file system, which means that it is a key value pair file system, key value data store using SHA-1. Okay, so SHA-1, basically Git stores everything as a SHA-1. So SHA-1 is basically a hash that says that, okay, I take your whole file and then I let it go through a mathematical process and just generate a string. Okay, a string that uniquely, hopefully uniquely identifies your file itself. Okay, so it stores everything as SHA-1. So maybe you'll be thinking, if it's like that, then what if one day 2 different files share the same SHA-1? Will it collide? Worst case scenario, it will happen in about 2 to the power of 61. Yeah, so it's almost very, very slim. It's like going through the whole earth 2 times and picking up the same grain of sand. Okay, that's about it. So don't worry about that. Okay, so in Git, there are 2 main types of object. So one is called block, which is the file itself. One is called tree, which is a bunch of pointers. Okay, so ideas shown here will be just a little bit and will be a tip of the iceberg, but it provides a little context for some best practices and workflows, so that you probably will understand like why did I say that this is the best practice. Okay, now for SHA-1, there have been proposals to replace SHA-1 with SHA-512, but not important. Okay, so let's use an actual repository. Okay, so my first time doing this kind of thing, them live drawing, so please also bear with me. Okay. So I'll be using draw.io for basically drawing my thing. Okay, I'll save diagram to my device. Create new diagram. Okay, blank diagram. So for this diagram, I will be talking to you guys about how Git actually stores its file. Okay, so for this circumstance, I would use this shape as the representative for commit. Sorry. Let me just refer back. Okay. Now I will use this shape to represent commit. Okay. I will use this shape to represent a tree and then for the actual file itself, blob, I will be using this. Okay, so it will be more easier for you to visualize. Okay, commit is this, tree is this thing with some slanted stuff, blob is this thing here. So how does Git store its file? Okay, so for this example, I'll be using this dependency thing that I've been doing for quite some time. Okay. Okay. So now let's get into the folder itself. Okay. So this is the Git command line. I'll just make everything bigger. This is a remote Raspberry Pi. That is not basically this is not my computer. It's the Raspberry Pi. So let me reshare. I think you guys can see. Okay, you guys can see now. Yeah, no. Okay, I think it's still quite slow, but yeah, just bear it. Okay, so list. So I'll be going into this thing called AICM, which is a project that I've been working on, and this thing is called IaaS. Okay, which means infrastructure as a service. I don't know why I named it that, but yeah. Okay, now if we look at the whole folder, we will see that we have this folder, this directory called .git. Okay, this .git folder here basically stores everything, which means your version history, your pointers, everything inside this folder called .git. Okay, so let me go into .git and list what is inside. So we have branches, we have refs. Okay, let's go to refs and see what's in there. Okay, we have heads, remote stash, and tag. Okay, so heads is basically like just now I said, pointers towards the latest version. Heads is basically a pointer to where you are currently at. Okay, so for example, let me take a look at this file file. So head, yep, it's here. So it's a directory. Let me just go into head, okay, and take a look. Okay, so now we have a head. Why? Because I only have a single branch. See, it's called main. So here I have a single branch called main here. Okay, so how do I know that what is happening around? Okay, so there's this command called git cat file -p for ppprint and main. So what is inside this main file? So basically within this main file, we have a few things. First is the tree. So where like which part of the file system you are pointing to, your parent, because this main points to a commit. So what commit is it? And for that commit, what its parent is. So this is the parent of it. Okay, who is the author? Who is the committer? Okay, and the commit message is down here. So the commit message for me is I rename the containers. Okay, so now we know that main has points to this tree. Okay, so let's copy the first few and say that, okay, now the tree is this. Okay, and main points to this tree. Okay, it points to this tree. So this tree points to this parent. Okay. Okay. So now we take a look at what is in here. What is in this 8C955. Okay. So the same. I just go back to my root repository because now we don't need anymore. Okay. So it's the same git cat file. Just copy this. Okay. So now git cat file you want to see that what is happening in this tree. So because it's so unique, sometimes you just need to copy the first few characters of it, and you will know where to find. Okay. So for now, you know that within this file, this tree called this, you have all of these files. So this blob here, so this tree here has this many blobs. Okay, all of these are actually files in my current Git repository. If let's say over here I say look at all files, view all files, you can see that I only have these few files here. Okay. Okay. So what do I have here? I have all this as blobs. So let me just copy it. Okay. 1, 2, 3, 4, 5, and then I copy the blob. Okay. So this one is supposed to be my gitignore. Okay. I'll copy this file name for a good reason. 1, 2, 3, 4, 5. Okay. Okay. Just for demo's sake, I'll copy another one called Docker Compose. Okay. So now we know that in this commit, it references to all three files. Okay. The reason I include these three is okay. License does not change. So okay. So this is deploy.sh. Okay. So these are the files that this tree reference to. So for example, so I just draw the lines of this. Okay. Okay. So now we have this. Okay. So now remember that just now that main has this parent here. So now let's check it out too. Okay. Git cat file. Okay. So it's here. Okay. So you can know that the tree is here. The tree is this file here. You can see it's like this. And you see that it's kind of different. Okay. Wait, this is the line of the last commit. Sorry, my error. This is the last commit. This should be this shape. Sorry, I'll put it in a while. Okay. Okay. So this is going to the last commit, and this is the tree for our last commit. Okay. So the link is basically like this. Okay. So this one, it then links to this line here, this tree here. Okay. And let's see. It links to 00 D18 here. Okay. So let's inspect it too. Okay. So now I realize that, okay, gitignore 69F3A, 69F3A. Okay. So this for this, it also refers to this, the same gitignore here. For the deploy.sh, does it refer to the same 993DA? 993DA, okay, refers back to the same also. So I think this one only changed Docker Compose. Yep, only changed Docker Compose. So this one is only referenced by this file, this tree up here. And for this one, it generates a new blob for it, which is this. Okay, so this is the Docker compose.final. Okay, and so forth. So Git is basically a system of many pointers. So for example, yeah, this is actually the example. So you just increase this indefinitely. So you just add this one, you just add a branch here towards the last commit and so on. So if let's say you check out this branch here, okay, you check out this commit, which is 42383. Okay, so let's say, for example, you do git checkout this. Oops. I think git checkout. There. Okay, now when we check out this thing, okay, now it's in the detached head state. So basically I can look around. So now my head, I use this as a representative. My head is now here. Okay. Previously my head is towards main and main is pointing towards here. So now my head is here. Okay. So for now I can see that, okay, now I want to check what is happening in head. So I git cat file. Hopefully I can check it. Okay, you can see that the tree is 00D18. So 00D18, it now shows that, okay, now I'm pointing to this tree, this commit that points to this tree, that points to 1, 2, 3, all these three files. Okay, so Git is basically just this kind of database. And the thing that makes it so elegant is because it just uses pointers, file pointers. So if you want to do anything, they just remap the whole file system and that's it. They don't need to rename your files, nothing. They just rename, or even if you are more familiar with Linux, they can just do a low-level symlink, and that's it. That's what makes Git so fast. Okay, so now, okay, so in Git, it is a very bad practice to detach your head or even to commit in a head. Why? Because let's imagine it like this, okay? You have a circle, you have commit 1, and then you have commit 2, and then you have commit 3. Okay, now commit 3 is based off commit 2, commit 2 is based off commit 1, and so on and so forth, okay? So, for example, if your head is here, okay? If your head is here, and it points to C3, okay? And let's say your main branch is around here, okay? Let's say your main commit, I put it as M1, okay? Now, this thing is based out of M1. There's no problem with it, okay? And the main branch is now pointing towards main 1, okay? Now, what happens if, let's say, you delete off head here, okay? You don't reference head anymore. What happens is that anything starting from here will be gone missing. Okay, let me repeat. Everything starting from here will be gone missing. Why? Is because the way that Git does, or the way that Git operates, is that it is based on references. So remember just now I said that, okay, that's this main file. It referenced this tree, and the tree referenced the last commit, it referenced the blobs and everything. So imagine this kind of circumstance where you know the head. Why you know the head is because it is in the folder called refs, RAFS. It's in the folder called refs. Therefore, it can scan the whole refs folder and say that, okay, head is in this commit. Okay, so it is here. So from here, you can trace back the whole tree to get back to your main branch. But once you delete this, it's gone. But it's not gone forever. It's just it's a gone reference, just like basically how you do a buffer overflow or memory leak in a C++. It's almost the same situation where the whole thing just went missing. You don't know where to find it. Okay, so when you detach the head, just be very careful that you are just checking out code and that's what you are doing. Because if let's say you do commit here and you forget to add a branch, then what happens is you will need to dig through the whole commit tree, which is here, cd.git. And then if I remember correctly, it will be in under object. Yeah, so everything will be inside here. And let's say, so let's say this is an object that has this thing. So you don't know what is it at the end, right? So it's in the best practice to not do anything with a detached head. Okay, if you really do something that has a detached head, you can solve it. Unfortunately, I don't know how to do it. You can refer to the Pro Git book that I recommended just now. Okay. Yeah, that's that's about it about the extra session. Because this is a more technical topic, that's why I don't want to merge it with the existing topic there. So I will look in the Q&A part to see if there's any questions. Okay, that's great. If you guys have anything, please go to Slido and ask. Okay, unfortunate. No. Okay, there's no question. Okay, while you guys are at it, please do remember to fill in the event feedback form. It really means a lot to me. Yeah. If you're on phone, then this will be the QR code. Okay. I think that wraps up our session. Thank you everyone for joining me for this really, really long talk of 3 hours. About 3 hours, almost 3 hours. Yeah. So thank you guys for joining again, and hope you guys have a good night's sleep. And yeah, please do fill in the feedback form. That's all. Yeah, thanks everyone.